All right, today we're going to tackle a foundational rule in algebra that can make even the most complicated looking math suddenly seem way simpler. It's called collecting like terms, and trust me, it's a total game changer.
I mean, let's be honest. Have you ever looked at an algebraic expression and just felt a little overwhelmed? It can look like this crazy jumble of letters and numbers, and it's tough to even know where to start.
Okay, so look at this thing on the screen. We've got D's, we've got T's, we've got some plain old numbers. It just looks messy, right? But what if I told you there's a super simple, logical way to clean this all up? By the time we're done here, you'll see this, not as a mess, but as a simple little puzzle just waiting to be solved. So how do we do it? Well, to get our heads around this, we're going to start with a really simple analogy. Just forget about all the letters and numbers for a second. Let's think about something you can actually hold, like building bricks.
Okay, so picture this. You've got a red brick. We have no idea how long it is, right? So in algebra, we just give it a name. Let's call its length x. That x is what we call a variable. It's just a placeholder for whatever that unknown length is.
Right, so what happens if you take 3 of those exact same red bricks and line them up end to end? The total length is pretty obvious, right? It's 3 times the length of that one brick, so you've got x plus another x plus another x, which, is a bit long to write, so we just write it neatly as 3x. Okay, cool. But what if we throw a different kind of brick into the mix? Let's say we've got these blue bricks, and they're a totally different length. We can't call them x because they're not the same as the red ones. So we've got to give them a new name. How about y? So if you have 2 of them, the total length is 2y. And this right here is the whole key to everything. If you have your 3 red bricks and your 2 blue bricks, what's the total length? It's just 3x plus 2y. That's it. You can't just mash them all together and say you have 5 red-blue bricks because that's not a thing. They're different. You've got to keep your pile of red bricks separate from your pile of blue bricks. So how does this whole brick thing actually help us with the math? Well, that's a simple idea. Keeping the red and blue bricks separate. That is literally the entire secret to cleaning up those messy expressions. See, in algebra, we have a fancy name for bricks of the same color. We call them like terms. Basically, 2x and 3x, those are like terms. They're both our red bricks. But 3x and 2y? Nope. Those are not like terms. That's a red brick and a blue brick. And that whole process of tidying things up, that's what we call simplifying. So when a math problem says simplify, all it's really asking is, hey, can you clean this up for me? And the way you do that is by gathering up all your matching bricks, collecting the like terms. All right, let's actually put this to work with a few examples. First up, 2x plus 3x. Okay, these are both x terms, so they're like terms. 2 of them plus 3 of them, easy, that's 5x. Next, 7y minus 2y, same deal, both are y terms. 7 minus 2 leaves us with 5y. Okay, now C gets a little more interesting. We've got 2 different variables here. So let's sort our bricks. First, let's grab all the p's. We have a 4p and a 2p. Together, that's 6p. Now for the q's. We have 3q and we're taking away 1q. That leaves us with 2q. So the final simplified answer is 6p plus 2q. See? We can't mix them. And finally, let's go back to that messy one from the beginning. First, the t terms. We have 5t and we subtract 3t, which gives us 2t. Then we have the plain numbers, which are also like terms. 7 plus 3 is 10. So what's our clean answer? 2t plus 10. Look at that. So much better. Okay, you've totally got the main idea now. Let's just quickly go over a few little rules. Think of them as professional etiquette for mathematicians, just to make sure everyone's work looks the same. So to keep everything looking neat and tidy, we all agree to write things a certain way. Like instead of writing 1a, we're kind of lazy, so we just write a. It's understood, there's one of them. And when you multiply variables like a times b, we just squish them together and put them in alphabetical order, so it becomes ab. And if you multiply a letter by itself, like a times a, we use that little power number and write a squared. These are just conventions, a shared language to make sure we all understand each other. All right, let's bring it all home. This isn't just some random rule to memorize for a test. This is a legit math superpower. It lets you walk into a chaotic mess of an equation and bring complete order to it. Seriously, if you walk away with just one thing today, let it be this. Collecting like terms is just a fancy way of saying sorting.
It's about looking at the mess, finding all the things that are the same kind, all the X's, all the Y's, all the plain numbers, and putting them into their own piles, just like sorting those red and blue bricks. And this is the golden rule right here. You group the like terms, you combine them, but you never mix them. Remember our bricks? You can add red bricks to other red bricks and blue to blue, but you can't just smush a red brick and a blue brick together and call it a new thing. They are fundamentally different.
So there you have it. You now have the power to simplify. You can look at a long, intimidating expression and turn it into something short, simple, and elegant. And that, of course, leads to the next big question. Once you've simplified it, what's the next step to actually solving it and figuring out what X is? Well, that's a puzzle for another day. Thanks for diving in with me.